So we haven't actually got the first page photocopied for some reason. I would like to go over it very quickly, however. They're always very, very similar in the non-calculator papers. Front page, nigh on identical every time. So it says, write down in words the number 35276. Now what I would do there is I'd go and write above it the units, the tens, etc., etc. By here. So then when you're reading them off, it makes it a little bit easier, so I can see that I've got how many thousands? 5,000s. Well, I've got 35,000s. So I'd say 35,000, 200s, so 276. Okay, so I'd recommend writing that out above the numbers. Okay, none of those can be in numbers at all. So you can't have the 6 as a 6. It's got to say SIX. And then for this one here, very, very similar. 16,340. So I wrote down my columns and then just filled in where the numbers went. Okay, using the numbers in the list, write down two numbers that add to 90. Now focus on this end digit here. That ends in a 0, so we call that a number bond. We're looking for numbers that end in, if anything ends in an 8, we'd be looking for a 2, because the 8 and the 2 make 10. That'll make it end in 0. So what I did here was I added together 52 and 28, and I got 80. These are supposed to make 90. So I checked through, were there any other 2s? 62. So what I did then was I add them together and look, it's made 90. I've checked by there. Okay, but it has to be from this list. Here, the difference is 67 and 24. Well, what I would be looking for you to do is actually go and do that as a calculation. 67 take away 24 is 43. Is 43 in the list? Yep, there it is. So that's 43. A multiple of 6 means it's in the 6 times table. So I wrote out the 6 times table until I got a number that was also in the list. And then the answer to 40 when it's divided by 5 is 8. The square of 8 means 8 times by itself, 64. Write down a factor of 24, which is between 7 and 11. I wrote down all the factors of 24, so numbers that times together to make 24, 1 and 24, 2 and 12, 3 and 8. I circled 8 because it's between 7 and 11. This one here then, it says round that number to the nearest 10. So I wrote it out again with its columns. When it says round to the nearest 10, you put a line down after the 10. This green number, if that's 5 or bigger, then this one goes up by 1 value. It's not though, so what happens is that stays exactly the same, and everything after the line turns to 0. Here, round to the nearest 1,000, exactly the same idea, except this time put the line down after the 1,000. Is this number 5 or bigger? Yep, so that one, he's going to go up by 1 value, that's why he's gone up to 8. Everything after the line turns to zeros. Okay, so that's the first page. I know you didn't have that, but I did want to go through it nonetheless. If you look here, they'll always ask for metric, okay? Now, metric units are the modern units, and they'll repeat themselves. So when you talk about the weight of 10 sheets of paper, if you talk about like the weight of a person, you'd say, Mr. Hall, so many stone, or maybe so many pounds. If you can have that word as in kilostone and centre stone, if you think, yeah, that actually exists, then that will be metric. But there is no such thing as kilostone or centre stone, okay? So it's not going to be stone. So I've got grams. Can you have kilograms? Yeah. Can you have milligrams? Yeah. What do you measure in milligrams? Any idea? Not centimetres. That would be actually measuring a length. You measure stuff like paracetamol and ibuprofen and stuff like milligrams. You'll have seen it on those boxes. Volume of tea in a cup. So you maybe think of pints, because you think, oh, you drink pints of Coke or whatever. But is there such thing as kilopints or centipints or millipints? There's not. So you'd have it as millilitres. Okay, you could have that as centilitres, and you can also have it as centimetres cubed. So that also. What's that? Sorry. Litres in the cup. So if you see my cup over there, that's actually 20 fluid ounces, which is a pint. A litre would be twice as much. I don't think anyone walks around drinking like a massive mug. So I'd actually mark that wrong. Starbucks, yeah, I suppose in Starbucks there is one, but maybe it's probably about a similar size. It's not going to be a litre. That's a pint of tea. It's a lot. It's a lot, isn't it? Height of a building. So that's going to be your metres. And the area of the ceiling in the classroom will be metres squared. Anything area will be its units squared. I'd measure this ceiling going in metres that way and metres that way. So you times them together to get your metres squared. Coming down for this one here then. Complete the shape so it's symmetrical about AB. The way that Lauren did it was she used tracing paper. So if you want to, you can put tracing paper over this. You trace, physically, you trace that shape there and the line. Then you get your piece of paper and you flip it and you match up the line again, and it should be symmetrical about that point there. I don't actually do that. Can you see, if I zoom in a little bit here, can you see I've actually got made a point there? What I do is I go and count where the points are. So this point here is 1, 2, 3, 4, 5 away from the line. So I knew it had to be 1, 2, 3, 4, 5 away from the line. This one here is 2 away, so 2 away. And then I join up all the straight lines and then do the curve. The common misconception people do is they don't know which way to do the curve. If you do the curve and it looks weird, chances are you've done it wrong, so only do it in pencil and rub it out if you need to. So, lines of symmetry, when it talks about lines of symmetry, thank you. Still waiting, thank you. Lines of symmetry is where you can fold that shape exactly in half. So that little lizard thing, that is literally just straight down there. It's like a lizard that's been run over, isn't it? Yeah. It's not sly, that's what it looks like. That's what it looks like. But it does. Lizards in a road, car wheel, over.
You could just say a lizard from a bird's eye view.
A lizard from a bird's eye view would be symmetrical about that point there. The other one, well, it wouldn't make it symmetrical then, would it? This one here, where can you fold it exactly in half on itself? Now, your lines of symmetry, you could use the tracing paper, but this would be quite hard. I think it would be a bit of a pain in the back side to try and trace that out and fold it, but you can use your tracing paper to do it if you really wanted to. Okay? The other one, probability scale, hopefully we're quite familiar with. It says the probability that the card chosen has a 2 on it. How many 2s have we got here? 1, 2. 2 out of 8, which is a quarter. Now here, this is 0, this is 1. This would be, right, Georgia, can you stop talking to me now, please? This would be a half. So in between 0 and a half would be a quarter. So that's why my A is bang in the middle there. It's not like, oh, somewhere down there. It's got to be in the middle between here and here. Okay? It's got to be in the middle of those 2 points. The next one, probability that the card has a number 4 on it. How many 4s we got? 1, 2, 3, 4, 5. More than half. So it's got to be up here. Okay? And then finally, the probability that a card has a number less than 5 on it. Well, every single number is less than 5. So that's got to be pointing at the 1. Going back to George's question, it's got to be here. You want to think about this. If this is in, 8 cards, then we want to chop that line up into 8 pieces. So if we chop it in half there, I've done it in half again there, each side. If I chop that again in half, there and there, there and there, that would now be in sort of 8ths. I mean, you could use your ruler to make it better, but this would be chop it in half once, chop it in those 2 half pieces in half, and then these ones in half again. Give me, it will say in between sort of like here to here on the diagram, and the examiner will have like a piece of tracing paper to overlay on it, and it's got to be within what they said on the exam, so it'll be something like that, somewhere between these 2 values here. Okay, good question. Board. The first thing I did was I actually went onto each bar and wrote exactly how many it was. So can you see there, I've gone and put 8 on that one, 9 on that one. Not a bad idea to do that at all. Different colour pens to sort of show the different bars so I didn't get confused in a bit. It says, on which day did Cardiff and Bangor have the same amount of sunshine? Well, it's when the bars are level, so that was Wednesday. The next one says, on how many days was the number of hours of sunshine less than 8? Now, less than 8 doesn't include 8, so it would be less than 8. It would be 1, 2, and 3. So there's a mistake there in the answers. That should be 3. Okay.
No, that's Bangor.
Bangor. Am I doing the wrong bit? Am I? Just checking. So it is 4. It'd be silly to cross that out and put 3. So I was doing it for Cardiff. For Bangor, how many days were there less than 8? 1, 2, 3, and 4. How many days were there more hours of sunshine in Cardiff than Bangor? That would be 1. And what was the total number of hours of sunshine in Bangor over the 5 days? That gave me 31 by adding together 9 and 6, so that's 15. Then adding the 4, 19, 24, 31 is definitely 31. And finally, the median number of hours of sunshine in Cardiff over the 5 days. So that is the middle one of Cardiff. So if I come back up to the graph here, I'm looking at the blue ones. Highest one is 9, lowest one is 3, so we discount those two. Then the next highest one is 8, and then the next lowest one is 4, so that leaves me just with the 5 there, so that's why that's 5. Okay? Okay then, so 124 times 36, you need to partition your numbers, so that 1 becomes 100, that 2 becomes 20, and that 4 becomes 4. So then you've got 3, which is 30, and 6 is just 6, okay? So the way that I always do these is I multiply the front two numbers. So 1 times 3 gives me 3, and then I add however many zeros, so the 2 there and the 1 there give me 3 zeros there to get 3,000. So for instance, this one here would be 6 times 2, which is 12, and then just 1 0 from the 20, okay? Then you line up all your numbers and you add them together and you should have got 4,464. When you've got 2/5 of something, the denominator always start by dividing by that. That little line there actually means divided by 5, and you divide 40 by 5, this number, to get 8, and then you multiply it by whatever the numerator is. So if it was just 1/5, you just divide by 5, because times by 1, it'll stay whatever it was, okay? So whatever that guy is, you divide by, whatever this guy is, you times by. So the answer was 60. And then the last one, you should be familiar with finding 10%. 10% should be a doddle, you divide by 10. If I know 10%, then I know 1%, just divide that by 10 again, but you've got to do it to both sides. So dividing by the 10 here just removes the 0, same here. And then finally, 6% would be 6 lots of that. So I've times this side by 6, so I must times this by 6 to get 24. I hope that this question isn't actually posing any issues at all. When it says measure the length of DE, it means put your ruler 0 on D and measure it to E, okay? I've got that at 8.6. You can be about 1 millimetre above and 1 millimetre below. There shouldn't be any watts going on there. Centimetres, yeah.
So 8.3.
I got 8.2.
Now, I got 8.6 from the mark scheme. What tends to happen when you photocopy is it does get shrunk down a little bit. So maybe 8.3 it would be doable, so 8.2 maybe just on the safe side. But check it, measure it. If you can prove to me, then I'm more than happy to agree with you. Okay? Name the line that is parallel to CD. So that means if I put my ruler like resting on that line, where can I pick up my ruler and put it exactly in the same place without rotating it around? Nicole? FE, fantastic. Or EF, either way round is fine there. I tend to do them alphabetical order, but it doesn't matter. Perpendicular to AC, this word perpendicular means right angles. So here's AC, what makes a right angle with AC? BE or EB, either way round is absolutely fine, well done. Right, the next one, you need to have a protractor for. And it says, measure B to F to E. So that's going from B to F to E. That shape there, that angle there. Now, the one thing I can tell you is that is clearly an acute angle. So there's no way you should be getting anything bigger than 90. You need to put your protractor on the little crosshair, would have to go on F, and 0 would have to be on this line here. And you would go and measure this angle here. I've got it as 54. Okay, and I've actually just been with someone who had exactly the same, so I'm quite happy, so that's still definitely 54. And then for BCD, so where are we? We're at B, we're going to C to D. Well, the opposite of last time, I can tell you that is more than 90 because it's an obtuse angle, so it's got to be bigger than 90. It cannot be less than 90. Crosshair on your protractor goes there. 0 goes on this line here. Measure it. 156 degrees. Okay? So, can you see there, I always write this, I stole this for someone in my year 11 class. So they write the acute and actually make it look like an acute angle. So that stops being an acute at 90. And there's also one for reflex as well. It's like an R. So, you know, maybe just that silly little thing that sticks in your head and helps you out in the exam, because I can quite clearly tell you now that that's a reflex angle. Reflex angle bigger than 180, which is a straight line, but less than 360, which is obviously a full circle. By shading 4 squares, someone asked me then the difference between acute and obtuse. So acute, can I draw on this? Yeah.
shorter than 90.
So here's 90. Acute would be smaller than that, whereas obtuse would be bigger than your 90. So if I sort of draw in like a dotted line, yeah, and less than 180. So somewhere above there, but below that, but more than the 90. Okay? It says by shading 4 squares, complete the shaded pattern below. So 4 squares here. Okay, the way that I do it is I go and look at this square. Is there one on that side that's also 1 square away from the line? Yeah. This one here is touching the line. Is there a square touching the line there? No, shade it in. Same here. Is there one that's 2 away? No, there's not. Shade it in. Is there one that's 2 away? No, there's not. Shade it in. Is there one that's 3 away? Yes. Okay then, so looking at this one here then, so a little bit like the net of a Toblerone box, you had to make sure that these lines were drawn accurately. If they're not drawn accurately, you can kiss goodbye to your 4 marks. Now on your paper, this will be exactly 6 centimetres here. This will be exactly 10, exactly 4. Okay, it may be that it's a little bit less on your drawing because photocopying is sort of snipped it down a bit. Okay, now what a couple of people did, and I thought quite cleverly, thank you, is instead of using a compass like I did to sort of measure this bit here to get in the compass to cross over at what about this point here and this point here, and then drawing up 4 centimetres, they actually use the symmetry of the shape to draw a line straight down the middle and just say, well, it's got to be on that line. So if you look there, that point there, this point here should be in a straight line with that point there. You can use that. I thought that was really clever. You then make sure that this is measured at 4 centimetres and 4 centimetres. And then this one must be 4 centimetres because when it folds up with this one, they've got to be the same when they fold up. Okay? And then that should have just been a case of joining the lines. But I thought that was a lovely 4 marks.
Okay, as Mr. Ashens said already, he's got a few hints here. He's put down that length there is X. That also means that X, that's X, and that's X. Why? Because we know there's 6 identical square tiles. So the length and the width for all the square tiles are exactly the same. So when the question asks us down here, write down in terms of X, the length of the rectangle. Well, we've got X, X, another X here. We add them all together, that gives us 3X. Okay? Part 2, what is the width? Well, we've got X here, another X here, that gives us 2X. Okay? Part B, the length of the rectangle is 15 centimetres. What is the value of X? Well, we know we got 3X here is the length. So we've got to equate 3X to 15 centimetres. So if 3 lots of something is 15, we know 1 lot of something is 5.
Yeah, just
X
if you do leave
equal
your
to
past
5.
papers here. Said a parallelogram is a pushed over rectangle. The first thing you should do is draw the base of your parallelogram, and then you need to draw an angle of 55 degrees. Now that I've just done by eye, and I'm looking at it now thinking there's no way that's 55, that's probably quite a bad drawing of 55 degrees. 55 is probably more like that. You need to measure accurately from that point there to that point there has to be 7. You need to go and do an identical thing over here, but that 55 isn't this angle here, it's this angle here on the outside. And then that line there must also be 7. The alternative way of doing it, like Brandon said, is if we said, look, we know there's 55 outside there, is you could do 180 because of angles on a straight line, take away 55 to work out that being, what, 125? And measure 125 there coming out, but again, that must be 7, so then it's just a dot-to-dot drawing there. You just join them up, okay? This is the first time we've all seen this question. We said a cube number is times by itself will be a square number, then times by itself again. So 1 times 1 is 1, and then times that by 1 again is still 1, okay? 2 times 2 is 4, and then times that by 2 is 8. 3 times 3 is 9, and then times that by 3 is 27. Oh, hello. He's in our range. Cheeky, cheeky. So 3 times 3, and then times by another 3 gives us 27. Write down all the prime numbers. Now, I would be here until after my all-you-can-eat feast that I'm having in a bit. Remember, it says range of 25 to 35, so it only wants the prime numbers up to there. So forget about, okay, what is a prime number? What's it mean to be prime?
Oh, so it's times by itself.
Times by itself and 1, okay? So if I write down this number here, say 2, what numbers times together to give me 2?
2.
1 times 2, that's it, isn't it? Okay? So that is a prime number. I get the tick.
3's a prime number.
3 is also a prime
1
number.
and 3.
1 and 3, is 1. What numbers times together to make 1?
1.
1 times 1 times 1.
Oh my gosh.
Okay?
Oh, yeah.
So, how many factors, how many different numbers go into 1?
1.
Just 1. To be a prime number, you've got to have 2 numbers that go into itself and 1, and that's it. So 1 only has itself.
What is itself?
Exactly. So this does not be a prime number.
It itself and 1 goes into
Exactly. So how many factors has it got? How many numbers go into it? No, it's got the same repeated factor, so it's only got 1 factor. So this is not a prime number.
I really don't like the number 1.
I can see that. If I looked at another number, we said 3 was because only 1 times 3. What about 4? Yeah? Well, certainly 1 times 4.
It's not 2 times
2 times 2 is not then. Okay, because this has got more than 2 factors. It's got 1 and 4 and 2. So it's got 3 factors. 5 is...
5 and 1.
Now 6 can't be because it's what sort of number?
Even.
Fantastic, it's even number. Any even number apart from 2 is not prime because 2 goes into every other. So 7 is, 9 is not, we just did 3 times 3 is 9 a second ago, didn't we? 11 is, 13 is, 15 is not, it ends in 5, so it's in the 5 times table.
Oh, we got to write all these down.
No, you don't need to write this down because
Is there an easy
it's
one?
between
No, it's not in
25.
between them.
Okay, so that's why I'm not too worried about them at the moment. 17 is, 19 is, 21 isn't, 3 times 7. 23 is, but it's not in our range
Oh,
yet.
you need to keep going.
25 isn't because it ends in 5. 27 is not, it's 9 times 3 makes 27.
This is 9.
29, so no even numbers,
Oh, yeah.
okay. 29 is prime, okay, so that is going to get the tick. So 29. 31 is also prime. 33 is not 3 times 11, and then 35 is in the 5 times table anyway,
So
okay.
29 and 31.
So 29 and 31 is the ones I've just got then. And can you see there, I've written down why I got that.
You have to do that.
You don't have to do it. As long as you say these 2 numbers here, you're going to be fine. Okay, when it said... Thank you. Thank you. When it said 5 squared times 2 to the power 4, I wrote down what it means to be 5 squared. So 5 squared is 5 times by itself. 2 to the power 4 means 2 times 2 times 2 times 2. It means there's 4 of them there, timesing each other. Now what I would do is I'd physically go and answer each step of that. So what is 5 times 5?
25.
25. Times it by 2, double it.
50.
50. Times that by 2.
So fast. 100.
100.
Times that by 2.
200.
Times that by 2.
400.
400 exactly. Okay?
Oh, so fast, man.
So what I've got here is that answer there. 400 is my final thing. But can you see there, I've just written down what I was doing. You wouldn't have to. You could go straight to that answer if you wanted to.
It's 5 times 5 times 2 times
7.5 subtract 4.27. You need to set up in the column method. Make sure that you line up the units, the tenths, the decimals, the hundredths. Now there was no hundredth here, so I put it in. Nothing. A 0 represents nothing. Now, nothing take away 7. Be very careful. People put 7 there all the time. If I have no pounds, can I go and buy something for 7 quid?
So you got to get 4.5.
Get
You
10.
can't. So you borrow it. You borrow 1 from here to get that as 10, and that goes down to 4. 10 take away 7 is
3.
3. 4 take away 2 is...
2.
All right, and what's it say? I want to cancel it. Is 2 decimal points to line them up with each other, and then 7 take away 4 is 3. Okay, so 3.23. Now, the proper solution to this is as follows. 0.4 times 0.4, at first you think, oh, I have no idea at all.
4 times 4.
If you times it by 10, and times the other one by 10,
Is it
you get 4 times 4, which you do know. That's 16. However, we now need to do the opposite of timesing by 10 and times by 10 again, which is dividing by
10.
divided by 10 and 10 again, which would be the same as dividing by 100. Okay. So it's 0.16.
I would have just
Okay.
literally forgot about the zeros for a minute and just done 4 times 4.
That's actually the trick that me and Sir use. We were talking about it the other day, that you say, look, how many decimal places are there this side? 1. How many this side? 1. So 1 and 1 make 2. So 4 times 4 being 16, but it's got to have 2 decimals, 2 numbers after decimal point.
I literally just forgot about the 0 and the point. 4 times 4, 16, then just add the 0 and the point.
Okay, well, if you know how to do that, that sounds great.
That's what
And then this one here, to subtract fractions or add them, they must have the same denominator. Now I spotted this one went into this one, so I made them both 6. If they don't, multiply these two numbers together. But they do this time. So double that one, but you must double the top. Whatever you do to the bottom, you must do to the top. Well spotted. So we get 5 over 6, which is just this one here. This changes to 4 over 6. 5 take away 4 is 1. And then 6 over 6 over 6. They all remain as over 6. If you think of it, that you had 5 out of 6 slices of pizza, but then Mr. Hall was really hungry and took 4 of your slices, you would only have 1 slice out of those 6 remaining. Okay then, so first things first, how far was ABBA from Clive when he started out? Well, where was he? Well, he started by here. And it says distance in miles from ABBA, and he started there, which I went up and just counted the little squares and said it was 6. That scale was easy enough to work out. It's this scale down here which is a bit of a pain. Now what I did was I said from 11, let's go back there, from 11 to 12 is 60 minutes. Do we get that idea? It's 1 hour, I know, but 1 hour is 60 minutes. How many little squares fit in going from here to here? Careful. Whoa, hang on, too many people talking over me. How many little squares fit from here to here? 2 big squares, 20 little squares. Look, 1, 2, 3, 4, 5. Yeah, there's 10 on each box. Okay, I'm talking little squares. Okay, so doing the calculation, 60 for the 60 minutes. So doing the 60 from the 60 minutes divided by 20, as there were 20 little squares in that jump, gives me 3, which tells me what 1 little square is worth. Okay, so that's a very, very, very important thing to have on your working out there. Okay, so I definitely get that in there for you. Okay. Now, you were then asked, you said, how far did you travel in the first hour? So the first hour came up to here, which was 37. But remember, he was 6 miles out when he started. So you needed to do the calculation, 37 take away 6. Very easy to miss. If you wrote 37, it's wrong. It needs to be 37 take away 6. Because he was 6 miles out when he started, as I've already said.
I can work that out, so I don't know.
Well, you can after I've been through everything. So it's 31 miles, okay? How many minutes did he stop on his journey? Now, he stopped on his journey when it went flat. That's what a flat line parallel to the x-axis tells me.
Yeah, we've got 11, 12.
Is it 12?
Yeah.
That would be a typo on my part. I do apologise, okay? So that should say 12:12, and that should say 12:54. Luckily, it's not made any difference. How was I able to work out it's 12 minutes?
Because it wasn't in 3.
Because I know each little square is worth 3. Well done. Okay, so it's gone up 4 little squares. So that told me it was 12 minutes. Then here, I counted that as the o'clock and came back to 6 minutes. 2 little squares, 6 minutes, to get 54. 12 minutes to 54 minutes is how long? 42 minutes? Yeah, there we go. Look, and I've written it there. I said not 11:12, take away 11:54. I've said just, well, it could have been the other way around. You could still say going from there to there takes 42 minutes. And I wouldn't have actually lost my mark there because my minutes are still correct. It's just I misread. It should say 12 like you said. And then finally, what time did he arrive in ABBA? Well, if you come down here, zoom in. Well, each little square is worth how many? 3. So that would be 14:57, 54, 51. It's got to be 51, not 50. Okay?
So say if you don't clock that correctly.
Okay then. So I've got number 13 here. 13 bars of chocolate are only sold in boxes of 8 or 12. Gary wants to buy exactly 21 bars of chocolate. Show how he can do this. Now this is a little bit of just trial and improvement, really, of you having a bit of a guess. I found a way of doing it, which was 2 lots of 8 and a 5. So that was 2 boxes of the 8s and 1 box of the 5. which gave me 21 bars of chocolate. Okay, I don't think there's any other ways, but I might be wrong. For B, it says that Fiona wishes to buy fewer than 15 bars of chocolate. List all the possible ways. So I got 5, obviously, then 5 and 5, which makes 10. And then 13. What if I missed there? I missed a really silly one. Really obvious now in hindsight. I could have got just the 8, couldn't I? Okay, so there are 4 ways of doing that. And then C, it says show that it's impossible to buy exactly 17 bars of chocolate. So what I did, so I showed that you couldn't do it through like subtracting 5 repeatedly, showed that you couldn't do it through subtracting 8 repeatedly, I showed that you couldn't do it by doing 8 or 5 in either ways, and that's the only way I could think of doing it. So I said I have shown there's no way to make 17 in 5s, 8s, or a combo of the 2. Okay? I did. Why have I got the calculation 20 divided by 10? Why have I got that?
I don't know. Oh, because there's 10 boxes
Excellent.
and this big bit equals to 20.
Good. Okay, that's exactly right, okay? So because this is 20, I've gone from 0 to 20, that's why I've got 20 there, and 10 because there are 10 little boxes. So each little square is worth 2. That's what that calculation tells me, and if you just come around to the side, you'll see that it's exactly the same scale on the way going up, okay? Now that meant I was able to go and plot all my red pieces definitely very, very accurately, okay? Now you get 2 marks for plotting all of those. You'll get 2 if you plot all of them accurately. If you mess up 1 or 2, you'll get 1 mark. But if you mess up more than 2, good night, no more marks on that bit. So don't mess those up. Work out those scales, go and find out what it is. Now, it says what type of correlation. They're only looking for 3 words here. It will either be positive, which it is in this case, negative or no, not neutral, no correlation. Okay? By eye, draw a line of best fit. That still means you use a ruler, and you should try and get the same number of points on the line, above the line, as there are below the line. And I think I've just about got that, although Esther's got a different answer to me, and I dare say that yours is maybe more accurate than mine, because I've done it on the iPad. It's not that easy to draw the lines on. Okay? So what I try to do is try and draw my blue line. That line doesn't need to go through 0, 0. If it does, it's just a coincidence. It doesn't need to go through there. And then I read off at, what must that be, 56. I read off at 56, I drew a line up till I hit my line of best fit, and I got 66. Now, if my line of best fit, I may lose a mark, but as long as I've gone up from 56 and read off that value correctly, I will get the mark there for the next bit, okay? So they may penalise my line of best fit there and give me 0, but they may give me 1 there. And is that the last question? Oh, that's the last question. So, there's a couple of ways to do this, and what I did was I started writing down what was going on. So I said, look, I've got 1 block here, then I've got another 2, so that gives me a total of 3. Then I've got another 3, so that gives me a total of 6. So basically I'm going add 1, add 2, then add 3, add 4, and so on, and blah, blah, blah. So what I've done next is I've written that down here. So for 1 block in my staircase, I have 1. For 2 blocks, I had another 2. For 3 blocks, I had another 3. And I've said 1, add 2, add 3, add 4, add 5, add 6, add 7, add 8, add 9. Okay, now that comes to 45. You just need to take your time on that. I know it's an uncalculated paper. Just take your time. Okay, well that's what the answer should be, so I suggest that you get that down, okay? We're almost there now. We've literally got 20 minutes left. Yeah, quarter of an hour.
Oh, really?
That's all.
That's it. Almost
Get
done.
there for quarter of an hour and you're home.
And you'll have all the C grades. Yeah. And then what you can do is you can go on the bus, you can look through and relive how excited you were with all of these answers.
They'd be going in the bin. We're gonna watch Dave's Mac birthday.
Why did you even here for Miss Hockridge? She can go to and have really bag in school then.
That's a good idea. We can leave them here for Miss Hockridge.
Who's this?
Okay, now this question here for me did pose a few difficulties. It says a farmer grows 336 kilograms of potatoes and he sells them in 5 kilogram bags and 2 kilogram bags. He uses the same number of 5 kilogram and 2 kilogram bags. How many bags does he use? Well, I know he's got some amount of 5 kilogram bags, so I've called that 5x. I'm able to call that 2x because it says that he uses the same number of 2 kilogram bags, okay? And I know that comes to a total of 336. 2x plus 5x is 7x. And then what I need to do now is divide by 7. So what I've done by the side here, and made a small mistake,
Is this a calculator paper?
it's not, it's actually a non-calculator paper. This should be 8. Because you see, how many times 7 goes into 3? If I had £3, share it between 7 people. I can't. There's not enough many pounds. So you all get nothing, and I keep the £3 for myself. What really happens is that 3 goes over to the next column, and it becomes 33. So counting 7s until you get to 33. So that would be 7, 14, 21, 28. 35 is too much to come back to the 4 times 7, which was 28, with a remainder of 5. And then 7 goes into 56. 8 times, not 7. So that should be 8 there as well. Okay? Now, I know that I had x twice. I had it, so that tells me I have 48 5 kilogram bags and 48 2 kilogram bags, giving me a total of 96 bags altogether. Okay, so the big hint here, it says, one of the questions in their questionnaire, after they'd surveyed their customers in order to find out their opinion on alterations, says, what do you think of the fantastic new improvements? Well, if you start going putting in words like fantastic new improvements, you're bound to get only one answer. You might say, oh yeah, they're good. They're good. It's putting a doubt in people's minds. So I would, it's saying, giving people the idea the place is improved may influence how people respond. Now that would be an amazing answer to give an exam. But as long as you pick up the fact that they said, look, they're fantastic and new, then
Only
And-
one response.
yeah, and it's going to affect their response, clearly, isn't it? If I just said, what do you think of the place now, and just left it at that, I'm likely to get a much better response. If I said, oh, wasn't Sir absolutely brilliant when he talked through this question, I'm probably likely just to get people to agree rather than, people
To make
disagree.
you feel better.
It depends what the question is. Another question was, how often do you come to the club? Very often, occasionally. Now, I know Miss Powell's answer to this. She's going to say she goes to the gym very often. But I may only think I go often, but we go exactly the same number of times.
Do you go to the same gym?
Go to exactly the same
Johnny
gym.
don't even go to the gym.
Did you
David
plan-
Lloyd's on Newport Road. Isn't that right, miss?
Yeah.
She's there on the
I don't
badminton
think
courts, complaining of having tennis elbow, and we said, miss, you're playing badminton.
You didn't call it
Can't have tennis elbow. God. So,
We plan to be in the same
the
time.
problem is, we meet at the
We
gym.
don't actually go to the gym together with you, George. He
Oh,
just
I
think
thought
of a
maybe
name.
like he was like, oh, do you go there? I'll go with you.
Thank you. What do you see wrong with this question? It says, the question is very vague. People's opinions of often may vary and within what time limit? Very often when? How many times do you go to a week? That would be a better thing. Well, in fact, it says, write a better version. I've said, how many times do you go to the gym a week? Or how many times do you go to the club a week? 0 times, 1 to 2 times, 3 to 4 times, 5 or more. Okay? That covers absolutely everything. No matter what you are there, you've got a box to tick, and no point to my categories overlap. So if I'd said 1 to 2 times here, then said 2 to 3 times, that would be rather silly. Because 2, I could tick both boxes for.
Can you go there 0.5 times?
How do I go half a time?
Like,
You
you kind of get halfway to the gym and then go nah.
Well, I think the main thing is there, Georgia, is that I didn't go to the gym, did I?
You think it's in a shop and then you
Okay, what I've done first of all is to look at how deep the hole is. Okay, so it's 55 centimeters. Then it says the bug climbs 1/4 of a meter during the day and 1/8 of a meter during the night. It goes down, slides down 1/8 of a meter. So the first thing I've done is to convert those into centimeters. So we know a half of a meter is 50 centimeters. To get that to a quarter then, we just halve it again to give us 25 centimeters. And then 1/8 is a half of 1/4, so that's 12.5 centimeters.
Half of one.
So, here we go. This is our hole first of all. There's our bug. Okay, on the Monday,
looks a bit like
That's
Mr.
so
Hall, doesn't it?
yeah, I'd say. On Monday, he jumps up 30 centimeters. In the day,
He jumps up 25?
25 centimeters. There you go.
left to go.
He's got 30 left to go. Then in the night, he sliced down 12.5. So he's 42.5 centimetres away. On the Tuesday, he climbs up another 25 centimetres, but only reaches 17.5 centimetres. That's how much he's got left to go. When it comes to night, the owls come out, and he's got to go down to 30 centimetres.
The owl's starting to eat it.
On the Wednesday, he climbs up, but he's still got 5 centimetres to go. And in the night, when the owls come out, he's back down to 17.5. So, on the Thursday, he climbs up that extra 25 centimetres, and by this time, he is out. He's out, he's free. On Thursday morning.
And then he dies.
Okay, we've got a linear sequence here, and what we want to find out first of all is how much the sequence goes up in. So it goes up in 8s, add an h each time. Whatever that is, you put in front of the n.
It's minus 5.
It is mine. Just checking.
Mr. Ashton,
Just checking, sir.
just checking. So,
Well, look, he's got a
this
minus
wasn't-
five.
Why are you supposed to be
I'm
a
just telling you.
Well, you always can't ask to check out work.
This wasn't -3, it was -5. Thank you, Mr. Ashton.
Vital marks.
8n minus 5.
That's what's
Loci is our last question. Okay?
Loki.
Loci.
so high.
So, because A is there twice, it says the point's nearer to AC. So if I look at my diagram, which sort of gives away the whole question now, it says AC, which is this line here, and AB, which is this line here. Where do these two lines meet? Well, here, at that point A. If that letter is there twice, it means you are going to bisect that angle. So what I did was I got my compass and opened it to about 3 centimetres, maybe 4. I put the point there. I drew a circle like that, but I only need it to cross the triangle here. Okay? Once I've done that, I put my compass here and draw an arc like that. I then move my compass up to here and draw an arc like that. Where they cross, I join up that line to the angle A and I bisect that angle. So this angle here and this angle here, these two should look identical, which I think they do. Next, it said points that are 5 centimetres greater than or greater from A. So I measured 5 centimetres with my compass, drew the green line, and then I said because it wants greater than 5 centimetres, that's everything here, but it wanted everything less than this line because it said nearer to AC. So that's how I shaded the orange bit. For the final bits, when you've got indices here and you're dividing them, you subtract those indices. So 8 minus 2 gives us 6. And then here, I expanded out the brackets to get 3x plus 27. And then I have minus 3x on each side, gives me 5x plus 17 equals 27. Then I subtracted 17 to both sides to get 5x equals 10. Then I divided both sides by 5 to get x equals 2. And we have finished the paper.